In this new unit, we're going to be looking at gases. And if you're following along in your textbook, this is chapter 8 of the OpenStax textbook. So you'll definitely want to be reading through this as you're going through the videos as well. And just to review, gases are a state of matter in which there is no definite shape or volume. The molecules don't adopt a shape or volume except of that of its container. And so imagine if we have a container of gas molecules. These molecules are just moving around, colliding with the container. They bounce off, keep on colliding, and so on. Sometimes they'll collide with each other, but they're just moving around in that fashion. And we can explain the activity of a gas using something called the kinetic molecular theory. You might see it abbreviated KMT. And this is just a model. So it's a pretty accurate, but it's still an approximation. And I just want to kind of in this video quickly cover some of the tenets of the kinetic molecular theory and how we're going to be treating gases in this chapter. So first of all, we treat gaseous molecules as spheres traveling in a straight line and only change direction when they collide with their container, or I should say the walls of the container, or other molecules. Now, that straight line could be in any direction, but they're just going to keep on moving until they hit something. Secondly, the size of the particles or molecules of a gas is negligible. And what I mean by that is if we have a container of gas and we have, these small little gas particles in there and they're moving around, that most of that container is just empty space. In fact, about 99.99% is space, and only about 0.1% is actual occupied by anything. And that relates to an important property of gases that they are very compressible. Because there's so much space in between them, they can be compressed into a small amount of space. Now, another property of gases known as pressure comes about from collisions with the walls of their container. In fact, that's the principle of blowing up a balloon. So imagine we force air into a balloon. That's a great balloon. But the way that that balloon stays inflated, as long as it's sealed, is these gas molecules are colliding with the wall of the container. And that creates pressure. The fourth thing is that when they do collide, collisions are elastic, meaning there's no attraction or repulsion between the molecules. And so when you have one gas molecule and it collides with another one, they're going to bounce off each other and leave with the exact same energy as they came in with. That's what an elastic collision means, is that excuse me, there's no loss of energy in that collision. Unlike, for example, say like a car accident, when two cars collide, then, both of those cars stop and they don't just bounce off each other and go on their way. There's a loss of energy in there. And then finally, the last one we'll look at is that the temperature of a gas is proportional to the kinetic energy of the gas molecules. And the way to think about that is that a gas that's at a higher temperature or a hotter gas is moving faster than a colder gas. All right, so in the following videos, we're going to dive a little bit deeper into the various physical properties of gases and looking at kind of the mathematical relationship between all of these properties. How does pressure affect volume? How does temperature affect pressure? How does the amount of gas affect all of those things? And so we will dive a little bit deeper into all of that.